Good day, campers, and welcome to the end of a phenomenal first week of Maker Camp 2013. For today, we got a special treat, a field trip to an amazing facility, Oracle Team USA's base camp, where the America's Cup trophy is being defended through the building of amazing and absolutely stunning boats like this one sitting behind me. We've got together a crew from some of the facility here that will help us explain what is exactly being put together on the site, how they got started, some of the jobs that they do, and just exactly what types of things we can expect to see with America's Team Cup. In order to help understand what we're talking about, take a peek at this video, and then we're going to jump over to M to give you a little history of America's Cup.
Through the jobs, we've been experimenting with a few different methods, Jimmy and myself, and obviously in these big cats there's a period where the helmsman has to run across the boat, and basically I'm sort of steering when Jimmy's crossing the boat, and we're trying to get our jibes going really well, trying to stay on the foils as best we can, and yeah, we've been trying a few different techniques, but it's coming along really well. It's amazing. A few times there I get to steer in the straight line, and yeah, just keep it on the foils. It's so much fun. It's like huge adrenaline rush, and I'm loving it. I'm very fortunate that I'm in the position where I get to steer.
Yeah, we had 2 fantastic days. I mean, to be honest, it's been a couple of tough weeks for the whole team and the whole community, really, with what happened to Andrew, for Bart. And I think it's just a big step for the whole team psychologically to get back out on the water. The last 2 days have just been absolutely fantastic. I mean, the breeze, seeing all our competitors on the water, and just getting some fantastic sailing out there. So, big step. I think everyone's back on the horse now. Really looking forward to just taking some more steps forward.
Thanks, Mike, and welcome back, campers, to day 5 of Maker Camp. We are here live at Oracle Team USA headquarters in San Francisco, and today we're talking with Director of External Affairs and Vice Commodore of the Golden Gate Yacht Club, Tom Eamon. Nice to meet you, Tom.
Good morning, Em. Thanks for having me.
How are we doing today?
Very well, thanks.
Great. So we wanted to ask you a few questions and kind of run through some of the history of the Oracle America's Cup, or America's Cup, yeah. So first question, what is your job and role on the team?
My job is to deal with the other teams, the external entities, the other teams, the governments, negotiating the rules, the politics, and that's essentially it, as well as advising within the team what's legal and fair and what's not.
Interesting. All right, all right. And what would you consider the best part of your job?
Best part of my job is actually completely unrelated to that. I get to host the VIP guests on every race day, give them a little history of the America's Cup, give them an America's Cup 101 on why this is the oldest trophy in sport, why it's the most exciting, extreme performance sailing event, pinnacle event
Yeah.
in the world today.
Great, great. Do you want to tell us a bit of the history of the America's Cup?
In a nutshell, in 1851, speaking of technology, the first ever World's Fair was held in England. Queen Victoria hosted it and invited the nations of the world to send their best examples of technology, including sailing technology, because in those days, how did you get the goods to market?
Sailing.
Big
Huge,
sailboats, right?
enormous sails.
Clipper ships,
Yeah.
tall ships. So who has the best sailing technology would be interesting at a World's Fair in the middle of the 18th century, of the 19th century, the middle of the 1800s.
Right.
So they had a race around the Isle of Wight. The only country to send a sailboat was the United States, and they kicked the butts. They beat the Brits around the Isle of Wight in this 7-hour race and won this trophy that was given to them, originally called the 100-pound cup, like British pounds, not
Wow.
because it weighed 100 pounds, but the currency. And the media since has called it the America's Cup after the name of the yacht America, that first won it.
Wow. Great, great. All right. Well, let's get to the next question here.
It's good you're using a
Right? Yeah.
iPad instead
I
of
know.
a pad of paper. It's very modern.
Exactly. So, who would you consider to be your hero in this particular field?
Probably in the America's Cup.
Sure, sure.
In the old times, probably Harold Mike Vanderbilt, who was very interested in science, technology, engineering, math himself.
STEM.
STEM.
Right.
Not only was he the winner of the Cup in 1930, 34, and 37, but he was a Renaissance man interested in many different fields. He was the inventor of a contract bridge, as well as a yacht designer and the inventor of the modern racing rules. So I like to say both sides of his brain worked. And I would encourage any kids that are interested in getting involved in the America's Cup to go to school and learn science, the STEM, the science, technology, engineering, as well as the communications and verbal and art side of your brain, so that both sides of your brain work.
Absolutely.
Modern day, I would say Russell Coots, who is the CEO of this team, who is the winningest sailor in the history of the Cup. He is an engineer by training, not a professional sailor. He came into professional sailing because he is strong in engineering. And if you look around Oracle Team USA, you'll find that just about everybody, my favorite topic in school was astrophysics, was astronomy. And here I am doing kind of legal and communications work primarily. But I think you'll find everybody in the team has some kind of an interest in or background in science, technology, engineering, and math.
That's great. That's great. So it's super important to be well-rounded, right?
For sure.
You know, definitely. Okay. So another question for you: have you personally mentored anyone in this field?
Yes, I have, and I want to start out by saying that I have been mentored and still am.
Right.
In fact, I'm driving over here to the Oracle Team USA base today. I was on the phone with one of my mentors talking about a very difficult and interesting topic that we have going on right now. And these are people who have been mentoring me for the last, I'm 60 years old, and they've been mentoring me for 20 plus years, almost 30 years. And I do the same. I think one of the best things you can do in life is to help other people, because my mentors have said, well, I say, what can I do for you? And they said, nothing. You can't ever do anything for me. We're well off, or we're retired, or whatever. But what you can do, Tom, is you can do for somebody what we've done for you. In other words, mentor some other young people. And I do that every chance I get.
That's great, Tom. Well, thank you for talking with us. We're looking forward to the America's Cup, and best of luck to you and the team.
Thanks, Em, and I hope that all of the kids watching this will encourage their parents to come to San Francisco to see the summer of racing here that's going on through September. Come cheer for Oracle Team USA or one of the other 3 teams that are racing from Sweden, New Zealand, and of course Italy.
Absolutely. Great. Well, thanks, Tom. We'll be seeing you soon.
Thanks, Em.
Absolutely. Thanks.
Nice to meet.
Thank you. And we're going to send it off back to Mike, and we'll talk to you soon.
Thanks, Em. I'd like to introduce all the campers to Grant Swimmer, who is the Chief Operating Officer of Oracle Team USA. And also, I'd like to make sure everyone knows we've got all of our camp counselors in Sebastopol. They're watching at the bottom of the screen there. So we've got a lot of people that are involved and engaged with this conversation here. Now, one of the things Tom mentioned was, these races, they're happening right now. My question for you, I think you've got the inside scoop on this. Where's the best place that we could watch these races happen?
The best place to watch is from Marina Green, and the boats will be right in front of you in San Francisco Bay. It's great. They're really close.
Fantastic. Yeah, so for those of you who happen to be in the San Francisco area, these are happening in the bay itself. Started this week, the lead-up races, and then once the qualifiers, the qualifier defender gets picked, the actual races happen in September, if I'm not mistaken, correct?
Yeah, so the process is the challengers are racing against each other. It's just starting now. We're the defender, so we wait for the best challenger to come along, and then we race them. So if you're really lucky when you go to Marina Green, you'll see us racing. And we sail our 2 boats out there, midweek mostly, Tuesday and Wednesdays normally. So if you go on a Tuesday and a Wednesday, you'll see us racing around the bay.
Fantastic. Now, there's also a website, americascup.com. Stuff's getting broadcast there. And also on NBC, if I'm not mistaken.
Yeah, it's live on NBC, particularly on the weekends, so you can watch it there. But it's good to go to the americascup.com and you can get the schedule of what's happening, or you can go to our site, Oracle Team USA.
Super. Now, as Chief Operating Officer, what are you tasked with? What are you working on here? I mean, this is an amazing operation.
Well, my job is to sort of look after the day-to-day activities of this team. We've got about 140 people working in this big shed at the moment, all sorts of different talents. Obviously, we have a sports team there, but we have the design team, we have the technology guys who are repairing the boats and maintaining them. We've got boat builders building boats, and then we have a marketing team, we have administration, everything we need to run a business of 140 people.
It's a lot bigger than just a boat and sailors. You know, you see this size of this space. It's immense and it's very impressive. What got you here? How did this happen?
So I've been involved in the America's Cup now for more than 30 years, and I've been doing things in between as well. I started off studying as an engineer, and I was always a sailor when I was a kid, and I was quite competitive, doing well in the sailing scene in Australia. And then I got involved in the America's Cup, and became the navigator of a boat called Australia 2 in 1983 when I was a young engineer, young sailor, and we won the America's Cup, first time ever in 132 years. So then the Cup went to Australia.
That's incredible. So as we just heard, you know, there's a amazing history. 152, 162 years of races that have been happening, and for a long time there was one winner, and then you guys were the ones that took it.
Yeah, that's right. The Americans won it first in 1851, and then they held it until 1983 when we won it. The Australian team won it, and when you win it, you get to have a very big say. You basically control what the next event will be like. So we took the Cup back to Australia, and we held the Cup in '87 in Perth. And lots of teams came then because they figured there was a good chance to win it. And then the Cup just continued to grow since then. And the most recent development is in 2010, we went from monohull yachts to these catamarans, really high-speed catamarans. So now, not only is it a sailing boat, but it's a foiling boat. So it sails above the water on foils. And we're doing speeds of 45 miles an hour, top speed. And so it's a different game. We're on the edge, really on the edge sailing. And in those days, we used to sail around at 9 or 10 knots and think we were fantastic, you know. Now the boys are doing 40 knots and hanging on.
So you've got an engineering background, and you've got to do some pretty amazing things with that. Got you to, you know, this is an incredible space. What types of tips do you have for some of the campers that might be interested in figuring out if this is something they want to do?
Well, the thing that got me into this is I enjoy the technology, and I enjoyed sailing, so I just did what I loved doing and what I was really keen on. So if people do what they're passionate about and they work hard, they'll achieve their goals.
There's 3 sizes of boats that you guys build. There's a 45-foot, 72-foot, and a mammoth 90-foot sailboat. What happens with these boats? What do you guys do with them?
Well, the really big one was for the last Cup in 2010, and so we're not using that anymore. But this boat behind us is the 72, and that's the boat we're going to race in the America's Cup. But there's also the 45-footers, which we've been racing a series around the world, going to regattas around the world. But the really cool thing that's happened over this year is that there's a Red Bull Youth America's Cup. And they're for teams of guys and women between 19 and 24. And there's been a selection series going on amongst international teams, and 10 of those teams are coming here in August. They're going to train, and they're going to race the first week in September, and they're going to have a series racing amongst the youth teams. And what we've seen is they're really good. There's 2 American teams, but there's a Swiss team, an English team, a German team, an Australian team, no less, and a Kiwi team. So it'll be a hell of a competition. And the idea of the Red Bull Youth America's Cup is to bridge, to allow young sailors a bridge to get into the real cup, you know, to play with the big boys, you know. And the reality is they're 19 to 24, but they're really good sailors, so they could easily make that transition.
Now the boat behind us, this is the 72-footer. This is the boat that you guys will be racing in the America's Cup. For the 45-footers, if some of these campers want to find out more how to get involved with the Red Bull Youth America's Cup, is there a place that they can find information about that?
Yeah, they can go to the Red Bull website about it. They can go to americascup.com as well. The selection process is finished now, so the teams are set for this event that's coming up at the beginning of September. But this Red Bull Youth thing will continue into the next years.
Great, it's fantastic. We've got, like I said, we've got a lot of campers that are watching, and let's take a peek and see if anyone's sending in any questions. We can get, while we've got you, see if we can.
Hopefully somebody's in there.
Yeah. Find here what we may have. All right, so we've got a question coming in from Google+. What's the world record for the fastest boat? How fast can the boats go?
Well, there's actually a competition. It's not the competition we're in, but there's a competition for the top speed in sailing, and it's a custom boat that actually skates along the surface, and it's got a sail plan like a windsurfer, so it's cranked right over to windward, and the top speed's about 60 miles an hour.
Wow. Okay, so these guys are going, you said you're getting up to 45 miles per hour, which is an impressive speed on the water. Yeah. 60 miles per hour sounds frightening.
It is, and the guy is actually an Australian again. I don't know why, because he's nuts, but he set the world record. Prior to that, it was guys kite surfing, but he built this custom boat just designed for a straight run, top speed, like a drag car.
Got it. Now, another question from Google+. People want to know what Oracle is. What does Oracle do?
Oracle is one of our major sponsors. The owner of our team is Larry Ellison, who is also the CEO of Oracle. Oracle is a database and a hardware and software company, massive corporation. And Larry's built that business from scratch to being a massive, one of the largest corporations in the world.
Fantastic. Well, let's see if we've got any last questions here. Okay, one more question from Aaron. Someone wants to know, Aaron on Google Plus is asking, what breaks most often on the boats? If something breaks while sailing, can it be fixed right then?
Firstly, the fact that we're going so fast in these boats means that any little failure is really quite dangerous for the guys on board. So what's going on behind us, there's noise behind us, is a very intensive maintenance and checking process. But we do occasionally break things on the water. Lots of things can break. Some of them can be fixed on the fly. If there's like electronic system failure, we can normally reboot the system, get it running again, or disconnect some hardware on board. But if we have a structural failure on the water, which occasionally we can get structural failures, we generally have to stop sailing, come back to the base, retreat, fix it, get back out the next day.
It's a big operation. I can see how it requires this much space. Well, I want to thank you for your time, Grant. This is Grant Simmer, COO of Oracle Team USA. And we're going to jump over now to the sail loft. M's talking to one of the sail builders who find out a little bit more about some of the stuff that's actually required when those rebuilds and repairs have to happen. M?
All right, thanks, Mike. So we are actually in the sail loft of Oracle Team USA. This is where they build the sails for one of the world's fastest sailboats. And we're going to be talking with Craig Phillips. Hi, Craig.
Hey, Em. How you doing? Very well, thanks.
Great. So this is the sail loft, and you are the sail loft manager.
Correct, yeah.
So let's talk about the sails. Right?
Well, first of all, I mean, we've got a 10,000 square foot space, which is unlike most other sail lofts in the world, and it's a nice, bright and open kind of feeling environment, which, you know, the boys here and myself thoroughly enjoy. And it's a great working space. So we're able to, you know, achieve and mass produce in an environment that is, you know, going to give us the, you know, the cutting edge that we feel to manufacture the fastest sails in the world.
Absolutely. So look at the size of this thing. It is enormous. How fast can this sail push the Oracle Team USA's boat?
Well, this sail here is 1,000 square feet. It weighs approximately 160 pounds, and it will drag the boat through the water at around about 40 knots.
40 knots, and that's in miles per hour around 60?
No, probably around, 40-something miles.
Oh, okay,
Yeah.
I see. So I notice you use the word drag through the water because that's literally what it's doing, right?
Exactly. So, like anything, and with aero, with a certain amount of speed, there's also you've got power to weight and drag ratios that we all have to consider. So, the bigger the sail, you may think it's going to go faster, but it gets to a point where it is too much drag.
What is that point called? Is there a technical term where the sail is actually too big and it stops being effective?
There's no actual technical. And out on the bay and deciding which sail would be best given the angle of the boat, sail to the breeze, and the wind speed exactly. So, but shall we go over and have a look at
Yeah. Let's talk a little bit about the material, maybe.
Okay. So we'll just get down here. Yeah. So the material is made from carbon fiber.
Oh, wow.
So this particular sail, being very, very stiff, is what we would call an uprange sail. So the sail is used for breezes or winds excessive of 15 knots. So we have a different range of sails depending on the wind strength, but so this sail is from 15 knots and above. So because it is in a heavier wind band, we have to make the sail stronger by the amount of fibers that are in the sail. So the fibers in this particular sail are made from carbon fiber and Dyneema. So the two fibers are married together on a two-dimensional plotter bed up in Nevada, and after they're all interlaid together, we then go and put the sails on a three-dimensional mold where they're cooked and then sent to us down here for finishing.
That's impressive.
Yeah. And then some of the details we've got here, just while you're here, is we have a finished, what we call corner here. This is what this is pretty much what you see the boys doing behind us here on the bench. They are cutting all these webbings piece by piece with a titanium ring, and then this is the finished product right here.
Gotcha.
You can't bend
Oh,
this corner.
wow, that's really strong.
Yeah. So the load on this corner, for example, would be around 10,000 pounds of pressure.
Just at this single point.
Yeah, so that's this corner, this ring could lift 6-7 NASCARs just up like this.
That's awesome.
Yeah. And the sail is held to the front of the stay by just a zipper. Just this single zipper that you would use on the jacket of your, you know.
Wow, that's impressive. So, so this single point takes 10,000 pounds of pressure?
Correct. Yeah.
And okay, so is there a way we can kind of tell how strong this fabric is? Is there a simple way to explain that?
Yeah, I guess to simplify the process, we have a bunch of designers that sit down in their little office and crunch away at the numbers, and a lot of that is based on experience, but we have the tools these days with the CFDs and VPP programs that allow us to understand the loads and the pressures on every single point of a sail, and that being every other part of the boat as well. So this particular sail in the middle of the sail is the lowest kind of load area, and as you start to get into the corners of the sail, the loads go up accordingly.
Understood. Wow. Okay, so actually, let's take a moment and see if we have any questions from campers. All right, here's a question from a camper. Where did you learn to sew?
Good question. My father taught me to sew. My father was a sailmaker. He's recently retired, but I learnt my basic skills with my father back in the early 80s, and my middle school back in Australia, during the early years of middle school, you did textiles as part of your curriculum. So I learnt the basics through my father, and then at school, and then I started a sailmaking apprenticeship in Australia, which is a 4-year apprenticeship, which gives you the basic skills in the first couple of years, and then they send you out into the real world to further your skills and expertise into making the bigger boat sails.
Very cool. So it's a family craft then.
It is a family craft.
Interesting.
And can you ask what's involved in sewing through carbon fiber?
So, say that again?
I'm wondering, how do you sew through a carbon fiber composite?
Okay, here's a question from Sam, one of our interns at Make. He wants to know, what kind of machine is capable of sewing carbon fiber?
Okay, well, we just happen to be there, Em. Right here, we've got Chris in the machine here, and this is a very, very specialized sewing machine. This machine actually costs around $40,000, but it's capable of sewing up to 1 inch of thickness to get through our heaviest corner for sewing the carbon and the webbings together, which we saw back on the other corner. So the loads on this corner are quite significant as well. And as you'll see, the pit itself, which the sewing machine is sitting in, recessed in, actually rotates 360 degrees, and that's obviously because the sails are so heavy that we don't want the boys that are sewing all the gear to be getting all twisted and bent out of shape, if you like. So it makes a more comfortable and easier process.
Great, great. So another question is, how long does it take to complete a sail?
It varies, but in general terms, on an average, probably 3 days. 3 days to build a sail, and they only last about 16 hours on the water.
That was going to be my next question there.
Yeah, I thought it may lead to that. So we replace a sail at around 16 hours. And at each sail costing around $40,000, you can understand that it starts to get quite significant.
Absolutely. Have you ever had a sail fail on a run or a test run?
Not on this particular boat, but in our past experience with other America's Cups, absolutely. And it's all part of the trial and error of building the lightest and fastest sails for your team and your boat at the time. So yeah, we try not to let that happen in a race, and we try to do it obviously in trial periods, but it's a little bit of trial and error.
It happens. It happens. So what would you recommend somebody who's interested in getting into sail making? Like, what kind of skills should they be focusing on? You know, that kind of thing.
Well, the basic skills always just, finishing school is always a good thing, obviously, and having a good understanding for math. You don't have to be no scholar or a dux at math, but in general terms, just a good education all round. Just finishing your, get good English and good math, and and a good eye-hand coordination with not trying to sew your fingers.
Understood. Understood. All right, I think we're going to go ahead and hand it back to Mike. And thank you, Craig, for sharing all that info with us.
Absolutely.
We'll talk to you soon.
Okay, cheers.
Cheers.
Thanks, Sam. I'm still trying to get my mind around the fact that these machines can sew 1 inch thick of layered materials. These sails are made out of some really, really amazing materials, but those machines, geez. Well, I'd like to introduce all the campers to Andrew Henderson. He's one of the sailors on Oracle Team USA, and welcome, and thanks for being part of this.
Thank you. It's very exciting.
So tell me, what's involved with being a sailor on this team?
Well, the sailors are intricately involved in a lot of the processes that go on during the day. So our day starts pretty early. We're 6:30 up and rolling the wing and the boat outside and involved in the launch process. And then come and get changed, get ready for the day, put on all our kit, and then out for anywhere between sort of 3 and 5, 6 hours on the water. Back in, get all the hardware back in the shed, and then debrief what's gone on during the day and make a plan for the next day and finish up, 6, 7 o'clock at night. They're pretty long days.
I can imagine. How many sailors are involved with this whole operation?
Yeah, there's between 20 and 25, and we have enough sailors so we can man 2 boats. So we can have 2 boats out in the water and we can test all our concepts.
How did you become part of this?
I joined Oracle for the last America's Cup, but I've had an interest in sailing for years, and when the America's Cup turned to these style of boats, it piqued my interest really quickly because of the technology and the wings and just the physicality of the boats. And I think a lot of guys are super interested in this new class because they're so extreme.
That's actually one of the things that I'd like to touch on real quick. The boats have changed through the years. How does that happen? Why are there changes in the designs?
I think what's happened, particularly in this manifestation of the class, is that they wanted to model the whole cup to the newer generation or younger generation, and to make it exciting, make it more like NASCAR and those exciting, visually exciting sports, and that's what's driven all this. And the big thing is to use the latest technology available as well. I mean, there's so much new technology become available to the class in the last 5 years, and to be able to showcase that has always been part of what the America's Cup's about, and that's pretty much manifested in these boats you see behind me.
As you guys saw in that lead-up video, these boats, they're not slow-moving sailboats. These are rocket ships on water. I mean, it's really amazing that these are wind-powered race boats. So when the sailors are out on the boat, there's a million things happening. And when you're moving at the speeds you guys get to, how do you stay on top of everything?
Yeah, well, there's a lot to think about, and a lot of it's in the training. And there's many aspects to the training. There's the physical side, the mental and the preparation of all the moves. There's a tactical side, and then there's a safety side as well. That if something goes wrong, then we need to know what to do. So I think when it's actually going on the boat, a lot of the moves are predetermined in practice. There's a playbook, and it's all about muscle memory and knowing what to do. Knowing what you have to do next in every different scenario. So a lot of it's practiced and learned.
I see that you brought a piece of safety gear right now. Tell me about this. What is it?
Well, because of the speed these boats are going, if something goes wrong or a situation changes quickly and we find ourselves maybe upside down or we've broken apart and there's sharp pieces around, we have impact protection on the life vests. We also have knives to cut ourselves out of any tricky situation. There's a comms unit that the skipper is broadcasting the whole time, so he's telling us what's going on ahead of time, so we know what the next move is. And then we have spare air, which is it's about 45 seconds of air if we happen to get trapped underneath the boat, give the rescue diver time to come and get us. So there's some pretty serious consequences if things go wrong on these boats.
I saw while we were taking the tour, I saw some of the sailors walking around, and these guys with the gear, with their outfits on. I mean, it looks like special forces members. This is, not boat shoes and sailor caps at this point.
Yeah, it's very different, and I think the gear reflects the nature of the boats. You need to be prepared for all sorts of different situations, but you also need to be able to move very freely around the boat and quickly. You need to be able to sprint from one side of that thing to the other in seconds, and the gear needs to allow you to do that as well.
They look like superheroes. It's really cool. It makes me want to get more involved. And this is it's turning into an extreme sport, really, like you said. This is.
And yeah, we've had a lot of kids through here. We do a lot of tours with kids, and to bring the kids up and show them the trampoline, it's got everything. You get to run a lot across the trampoline. That's a hell of a lot of fun as well. There's a serious side to it. There's a safety side, but the main thing, like any sport, it's a hell of a lot of fun, and that's what we're really having out there.
It's fun. That's the name of the game. Now, what tips do you have for any of these campers that might want to try to do what you're doing?
Yeah, I think with any sport, you've got to enjoy it first, and you've got to enjoy what you're doing and have fun doing it. And if you can make friends and in the sport you're doing, and you can have that journey with them, it's as fun as well. And something like this it's the top end of this sport, but it's accessible. It really is accessible, And if kids just put their head down, got a good work ethic, you can get there.
Fantastic. Well, speaking of getting kids involved, let's jump over to some of the campers and see what types of questions they have. You guys, do you have any questions coming from Make headquarters? You guys have anything you want to ask? All right. Sounds like
Nick, go for it.
Yeah, we'll just jump right in here. All right, so let's see here. Which one do we want to do here? Trenton. Oh, this just refreshed. Okay.
If I were interested,
Chris on Google Plus, he's asking us here, how much work do the sailors have to do to keep the boat at speed and keep it on course?
Yeah, it's constant movement. So I don't know if you can see behind me, but you can see the handles of the pedestals there, and there's 8 guys constantly turning those handles to power the winches and the hydraulic system. So the guys are using on an average training day up to 6,000 calories in that time. So, it's a lot of sweat, a lot of running and keeping fueled up, and it's a hell of a lot of work. Yeah.
I saw in one part of the facility here, you guys have one of the more amazing gym facilities, and everyone's using it. They're staying active and fit because this, like you said, 6,000 calories. You can't be out of shape to do that.
No way, and as you said, the training facility is amazing. They've even mocked up a life-size trampoline that we can practice on the handles and run across the other side and very much simulate what's going on the boat. I suppose what you can't do is simulate how active the boat is beneath you, and often it's changing as you're running across it, and sometimes you need to stop and grab onto the net, and every time you run across there is different. So we do a lot of work on stability to make sure that we can adapt to those situations.
A lot of core, people with kettlebells. I saw that they're stepping up onto the high steps. Yeah, it's good stuff. So Trenton is asking, do the boats go fast enough that they could fly if they had wings?
If only. That would be pretty cool. That might be coming with the next America's Cup, so stay tuned, but not for this one, I'm afraid.
What would you do if you were to design the next America's Cup challenge? What would your ideal challenge be?
Well, there's been a lot of criticism of these boats, but I, for one, really like them. I mean, look, they're drawing attention from all parts of the industry and the world for these boats, and because they're extreme, I'd go for something pretty similar and just use the technology that's evolving in the new class and make them faster and keep going down this track. I really think we've gone a good way here.
I'm blown away. I keep saying it looks like I'm standing in front of a fighter jet when you can see this thing face on, and it's got the wings that come out, and it's incredible. Well, Andrew, I appreciate your time, and thank you for giving us a quick tour of what you do and talking to the campers. Now we've got another person coming up who's got a very important role. He stands high above the operation and helps get the boats in and out of this facility. Give you an idea of what we're talking about. We've got a little video roll that we're going to queue up right now, and after that we've got Ron Esparza, who is the crane operator. Go ahead, check this video out.
just love running cranes. This is what it's what I love to do, and being able to work this wing because it's like I'm flying this wing. It's dynamic. It's not like a regular load that you do out on construction site. It's a lot of fun. It's great to love your work.
Probably out. Okay, a little swing left here on. Good to keep coming up. That's high.
So I'm pushing forward right now, and so we're coming down real easy. Just coming to 0. You should be stopping me here in a second. And then this control over here controls my trolley, so if I go out, it makes the load go further away or the hook go further away. And if I pull in, it brings it towards me. Pretty basic stuff. Right now we have some pretty turbulent wind, and that's going to make it a little fun for us when we first start. First thing is the beginning of it, because it's a wing. It wants to stay up. It wants to fly.
Okay. 3, 2, 1. I'm Ron Esparza, and I'm the crane operator for Oracle Team USA.
Incredible stuff. Ron, you're like a star to me. I mean, that's great. Now, this is Ron Esparza. He's the crane operator for Oracle Team USA, and he's got a very important job, as everyone that works here does. He's involved with bringing the boat in and out of the facility every time it goes out on the water. Why is this important? Why do we do it this way?
Well, it comes in and out of the water. One thing, keep the boat safe, bringing it out every night. They may need some testing or some work that needs to be done on it. And we do leave it in the water some nights. But when we leave it in the water, we have a full crew standing by, staying here all night long. So it depends on what the needs are for the boat, maintenance or security.
How does the process work when you're charged with getting the boat in or out? What's the step-by-step way that it has to happen?
Okay, well, first they roll out the platform, which is the boat, and the wing, and then they take the boat and put it out of the way, and then I'll step the wing, which you saw in the video. We'll stand it up, get it up. They'll roll the platform underneath the boat. We'll put it, we'll set the wing onto the boat, and then the riggers will go to work attaching everything and getting it ready to sail.
It's wild. Now, how hard is it to keep this thing stable as it's moving around?
It can get really exciting. The variations with winds changing, turbulence. The boat, it's real important. I gotta say, Jeff Causey, my rigger and signalman, has a very important role on keeping everybody coordinated. Because there's about 30 guys down there helping me out. It's not just me. We have to keep the boat facing the wind all the time. We have to keep the wing and the pontoons lined up. If they get out of sync, the boat will sail away. Even though it's not in water, the boat will start to sail away. So my ground crew has a very important job to make me look good.
And now I imagine the wing itself, this is designed to be thrown by the wind. Yeah. So that as well has to be an immense challenge.
It is, especially coming down, like I said in the video. It wants to stay up, and just our last night coming down, we're coming to bring it down, and it just stayed there. I had to go back up, catch it, and then bring it back down. It doesn't want to come down. I mean, our designers did it right. It wants to go.
How did you get started doing this?
Well, I've been a crane operator for about 15 years. Worked my way up into the trades. I have water work experience with cranes. And so I got a call, and I'm a union member, Local 3, and they called me wanting to know if I wanted to interview because of my water work experience, along with some other friends of mine, and along with my past sailing and whatnot, I got the job.
Now, if there was someone that were interested in getting involved and being a crane operator like you, would you say it would be important for them to not have a fear of heights?
I'm afraid of heights. I mean, you're going to have fear in everything. But I look at it is like I always challenge my fears. Now, maybe I'm not really afraid of heights, but I have a lot of respect for it. And there are times I get a little nervous up there because when I'm inspecting a crane, I may have to walk out to the end of the tip of the boom or walk up to the apex of it. And the wind's blowing, you're bouncing around. Of course, I am tied off. I'm not going to fall. But, I mean, there's some things you have to do that what the trick is, I don't look past my feet.
Sometimes it's hard to do that when you just want to look down and find out, and then you wish you hadn't. The crane itself, it's not anchored to the dock. How does that work?
Well, this crane is not. Normally in a crane, they build this huge cement block and they bolt it to it into the ground. But we're on a pier, so it has legs and a platform, and the platform is weighted down. Now there are bolts in it, but the bolts mainly keep it from sliding from shear. But without those bolts, the crane will not tip over. It's a ballast at the bottom that hold the crane down.
So, on a more real version of that other question I asked, if there were people that are interested, where can you point them to possibly get involved and start finding out ways that they can be crane operators themselves?
Yeah, well, kind of the best way and to get work, especially in California and different parts of the countries, we're a union state, and the best is with different unions, some operating engineers, Local 3, they have apprentice programs where you get on the list and you sign up and you fill out the application, and if you get picked, they pay you to learn. Your first day out, you're getting paid and you're learning how to run a crane or run a bulldozer, and you might do odd jobs like sweep or hold a stop sign, but you work your way up, and by the time you're done, it's a PhD, equivalent to a PhD, because we're trained really well.
Do you have a mentor?
I have a bunch of mentors. My friend Dick kind of got me into it and kind of helped me out a little bit along the way. You know, my mom, who is a big mentor, who didn't have education also, but she was so intelligent, so smart. People didn't realize the things she did for us growing up. Yeah.
You know, you said some stuff right before we jumped on camera together. You were saying some stuff about how a lot of this came to you because of hard work, which I think is really one of the things that's just so important, that people, they set a goal and then they push forward for it. And I think that's great that was one of the things that you really identify with.
Yeah, because like normal school education wasn't for me, but I get out, I worked hard. I still wanted to learn. It just, I learned different than the classroom or the book. I'm more hands-on. I'm very mechanical. So, you know, I took a lot of different steps to get there, but when I found something I enjoyed and I'm good at it, and it's great.
Yeah. And now you're part of one of the most impressive sporting team operations in the world. This is great.
Yeah, it's kind of amazing because I've been in sailing for 30 years, and I remember in '83 when the Cubs come back, I thought it would be great to have the Cup in San Francisco, to be able to watch it. And then to be a part of it is just incredible. It's a blast.
That's super cool. Well, let's see if the campers have any questions that we can jump to and get some answers here from you while I've got you on board here. Let's see here. We've got a question from Calvin in Utah. You might maybe have some information about this. How much does the boat weigh?
Well, roughly, I can't give you exact weights, but just under 7 tons. Yeah.
And the wing?
The wing weighs about 1.8 tons.
Okay, so yeah. Altogether we've got pushing in on 9-ish tons.
Well, actually, the wing and the boat in combination is 7 tons.
Got it. Okay. And how high up is the crane itself?
I'm at my hook height is 211 feet, and it's about 213 steps, ladder rungs to climb up. I actually counted it one day, and.
How tall for the wing for the 72-foot boats? What's the length of the wing itself?
What is it? It's 130. Basically 13 stories. It's a 13-story building.
It's incredible. And what I don't know if you have the answer to this one, but Sam's asking, how hard is it to remove the sail?
Well, for me, it's really easy. I just pull the controls. But there's a lot of rigging that has to take place. I take control of the wing along with Jeff, with my signalman, and we take certain weights as they have their steps taking the rigging apart. Hendo, who you just talked to, is really involved in that. And it's all teamwork. Without the team, it's not going to happen. And then when the wing comes off the boat, the wind takes over. So then it's teamwork controlling the wing, keeping it upright. Keeping the wing vertical really helps. Once it starts moving around or getting out of vertical or away from the wind, it wants to go. It wants to take off.
I mean, it's a dynamic, highly engineered piece of machinery. So I could imagine that it's
not like our normal load in the construction where. You put something here. Even the precision loads. This thing. It's not static. It's dynamic. It wants to go.
I appreciate you taking some time to chat with us.
Thank you, Mike.
And thank you very much. Now, as you can see, this is a very big operation. We've got people that run through all sorts of different processes and procedures. We've got crane operators. We've got sailors. We've got a whole marketing team. We also have some boat builders. And to get to the part where Em's going to chat with one of them, we've got a video that explains what the boat building process for Oracle Team USA is like. Let's jump to that. Then we're going to run over to Em and have a conversation with Andy, who's helping put together these boats.
All right, well, here we are live in the workshop of Oracle Team USA America's Cup, and we're visiting with Andy Walker, who is a boat builder. Hi, Andy.
Hi, how's it going?
Doing well, doing well. So let's take a look around. This is your portable workshop. It has a wide range of tools, anything from, I'm seeing some chop-off saws to some angle grinders, vices, we're seeing band saws, we're seeing mills, and all kinds of jazz. So this is your area. Why don't you tell us a little bit about your role and your jobs on the Oracle team?
Yeah, sure. As you can see, we've got all sorts of tools that are required to produce the race yacht, the race parts, the wings, and it's all custom designed, custom fabricated for its purpose.
Very cool. So what kind of things do you make in this workshop?
This is our woodworking area, well, woodworking and metalworking area, welding, grinding.
Very, very cool.
Fabrication.
Yeah, okay. So you produce a large amount of the parts that actually go into, say, moving the boat and things like that?
Oh, everything from moving it to sailing it to packing it away.
Very cool, very cool. So how did you get into, being a maker and getting into this workshop type situation with Oracle?
Just a lifelong dream, really. As a young kid, sailed when I was younger and was always interested in construction and engineering and studied it, and then you have to pay the bills, so chased the dream to become an employee for an America's Cup team, and I landed working for Oracle, Team USA.
That's great. That's great. You want to show us a little bit around your shop? It looks like you got some fancy machines with covers on them. Let's take that off.
All right. So this here's a vacuum pump we use to vacuum the air out of the composite laminate when we lay up the hulls. This is a 200 cubic foot a minute vacuum pump, so it's pretty powerful, and we need a lot of power to keep the laminate and the air out of our carbon sandwich.
Absolutely. Oh, so you do some carbon fiber work in here as well?
Yeah, oh, not in here, but out in the main shop we do.
Gotcha. All right. So you must be a huge fan of sailing. You know, you got into it at a young age, and you decided to kind of follow your dream, and it brought you here. So did you have any heroes or people you looked up to as a young guy?
Oh, for sure. You've always got a hero. I had lots of heroes growing up, and now I work for some of them, and have worked for some of the heroes when I was younger. And as you get older, you get wiser, and you slowly realise the importance of the person that you realise. So that's
absolutely cool. Great. What is this? Is this the steering wheel for the America's Cup boat?
It is. It's one of our steering wheels. We have two on each boat. Obviously, we've got two hulls, and it's built in house, all out of carbon fibre. It's hollow.
It's all carbon.
All carbon fibre. Hollow.
Wow.
Weighs. I'm going to talk in grams.
Okay.
The metric system. It weighs about 380 grams, so it's very soft. It's very, very light, and it's engineered obviously to withstand the rudder loads that the platform offers the boat.
So the steering mechanism actually gives feedback. Is that correct?
Yeah, you could say that. That's how Jimmy or Ben, our helmsman, can feel the boat. It's like driving a car or riding a bike. You feel how the boat's operate.
So is that a mechanical function, or is it drive-by-wire these days?
It's all mechanical. Yeah.
Very cool. So very direct feeling. I'm noticing some nodes around here with black carbon. And what are these buttons here?
Yes.
Right.
They're sort of a top secret sort of subject for what we have to offer for the boat, but I'll lead you into a little secret.
Understood.
It's like a computer game for the helmsman. He's always trying to keep the boat steady and stable. And these buttons here control certain functions on the yacht to keep it, you could say, level, balanced.
Yeah, absolutely. Wow, very cool. You want to give us a kind of a little walkthrough of some of these machines here and what you use them for?
Well, yeah. You've seen our vacuum pumps, and obviously we've got our lathes and our mills, and it's all comes from a block of, say, titanium or 17.4 stainless steel, and the designers give us a brief, some blueprints of what they want, and we jump on our machines and start fabricating them.
Very cool. So your title is a boat builder. So you have, I'd imagine, tons of machining experience.
Yeah, you're 20 years.
Wow, okay. So you're a pro. Big time pro. Cool. What are these for over here?
It's sort of deburring, sanding down anything from titanium or to steel, mild steel. It's just basically a high-speed sanding disc.
Very cool. So for kind of finishing off parts and cleaning them up a bit, deburring.
Yeah, because each part's custom, and if it's a little tight in one area when we're fitting it to a dagger board of the boat, we have to just mill it.
Definitely, yeah.
Mill or sand it.
Very cool. Do you do a bit of welding in here, I'd imagine?
Yes.
Yeah. What kind of machines are you working with?
Oh, TIG. MIG and stick, the whole array. Depends on the job.
Right, right. Very cool. All right, well, let's take a moment here and see if we have any questions from campers. Let's take
I'm
a...
wondering if they have any CNC machines in that shop.
Oh, okay, actually, Sam from Make is asking, do you have any CNC machines here?
We not on site, no. We contract out a lot of work to private companies, and in New Zealand we have another factory there, and we have 3 5-axis machines. One's 20 meters long, and the Z's 5 meters, so we can build big parts.
Yeah, that's a big machine.
Yeah, big machine, biggest in New Zealand. So it's and we have smaller machines ranging from just a 2-foot lathe, but we have, yeah.
Yeah. So where is that machine shop in New Zealand?
Warkworth, north of Auckland.
Very cool. So you guys literally send the files over to the machine shop in New Zealand, and they ship the parts back. What's the turnaround time? Is it pretty fast? You know, considering this is a kind of a big deal. You know, what if you need a part replaced? How fast is it going to be able to be put on the boat there?
It depends if it's like a big block of titanium or stainless, or it's fabricated carbon fiber, like if we build it with ourselves. We can have anything from 3 days to a week. It's very impressive the turnaround we have, and we have a good. It's a 12-hour flight to New Zealand, so
yeah,
it's here overnight. It's
That's impressive. That's fast. Wow. So can you tell us about some of the material changes in the boats over the years? Some of the more impressive advancements, like maybe the carbon fiber that you guys use. That kind of thing.
Yeah, it's changed over time with the modulus of carbon. In the rule, they keep it at a standard modulus of carbon, but over time, and the boats are developing, and the products are becoming trusted more. We're going up in modulus with our carbon to intermediate to high modulus carbon fiber.
So what's modulus?
It's just it's like tensile strength, how strong each toe or each fiber is.
Yeah. Great. So percentage-wise, what is the boat made up of? From carbon fiber to titanium, that kind of thing. What is the majority of the materials used?
It'd have to be 99% carbon, about 75% aluminium, and then the rest is titanium.
Wow, that's impressive. 90% carbon. Well, let's see if there's any questions from campers. Let's see. Yeah.
Do they ever 3D print parts before they ship it to New Zealand and get it back in the mail? Do they ever test it with plastic?
Right. So Nick from Make is asking, do you guys ever 3D print any parts?
We do. We're slowly getting into the 3D printing in our electronic side. We make a lot of custom electronic parts for the boat, and we have to have custom housings for it. And we used to make it out of carbon fiber, but that's quite a long process, and it ends up being expensive. So now we're using 3D printing to make these custom housings that fit exactly to the right spot on the boat, and
you can pretty much change them on the fly. That's great. So, it really increases your prototyping speed, probably gets you, the newest advancements in the least time possible, right?
Yeah, it's 3D printing's a wonderful product, I can tell you that.
Absolutely. Let's see here. So, we already talked about your hero. Let's talk about tools. What's your favorite tool?
That's a good question. My favorite tool is my toolbox.
There you go.
Because it's.
Is it around here? Can we?
It's in the other workshop, but it's got all of my tools I need to produce an America's Cup yacht. So there's not one favorite tool that I'd use.
Yeah. It's literally your entire toolbox. Very cool. So you guys move from I guess continent to continent. following this race. How long have you been with Oracle?
7 years.
Wow, that's impressive. So what places have you traveled to?
All around Europe, England, New Zealand, America. It's
very cool. Right. So if you could recommend anything to kids in terms of getting into a career like this, what would you say? Tough question, I know. Tough question.
It is a tough question. I guess if you're interested in marine and engineering, you just have to follow your dream, really. Follow what your gut instinct.
Yeah. So stick with it. Follow your gut instinct and work hard. I'd imagine is a big deal.
Exactly. There's so much to learn in this industry, and engineering, design engineering, and thinking outside the box is.
Yeah, very cool. What do you think is going to be the next revolution in the America's Cup boats? You don't have to divulge any secrets or anything. What's up and coming? Is it the sails? Is it the material science?
Yeah, I think it's the engineering and the application of the carbon fiber to the yacht and the wing. It's how you make it lighter and stiffer and build it quicker and safer. It's all a big calculation that this whole team works together, and that's
great. Well, hey, thank you for showing us around your workshop, and we really wish you the best of luck to Oracle, Team America, and Team USA, and we'll talk to you soon. Back to you, Mike.
Thanks, Sam. Thanks, Andy. That's fascinating stuff. I love tools. I love workshops. I love fabricating stuff. So I am here with Kurt Jordan. This is one of the boat designers. This from Oracle Team USA. He helps put together these incredible crafts in various ways. Thanks, Kurt, for taking some time to chat with us.
Yeah, no, it's a pleasure.
So tell me, what's the process when it comes to a new race is a challenge is posed, and Oracle Team USA says, okay, we're going to set some rules up here, and we're going to start putting together a new boat. What's the design process? What has to happen for that?
Well, the first part of the process is largely driven by the class rule. So we as designers are given basically a box that we get to design a boat into, and it has all the major performance parameters of the boat: the length, the width, the weight, the size of the wing sails. And then within that, we start to figure out how to optimize to make the fastest boat that will abide by all of those rules. And the process starts, very broad brush on the blackboards, with big parameters. Where do we want the weight balance? What are the things going to be the most important for making the boat faster? And then very quickly it goes into, kind of rough computer simulations of what those weight balance parameters and things do to help performance. And then it just continues to go to very sophisticated three-dimensional computer models of the boat, not only to visualize what the boat looks like, but to do stress and strain analysis, to do fluid flow analysis, things like that. So it's a long and lengthy process, but it starts on a blackboard.
You're largely part of the computer design element of that whole process, correct?
Yeah, I spend the majority of my time doing three-dimensional computer simulations of the structure of the boat.
And at this point in time, after the computer models are done, are they well designed enough that you can just start building something the size of what we've got behind us, or are physical models on a smaller scale that get made first?
Well, physical models are a big part of it. I mean, the computer, like all computer models, you've all heard the term garbage in, garbage out. And it's very important that we characterize all of the materials, physical materials that we put into the computer model. So we do a lot of small coupon testing of the carbon fiber to get its mechanical properties to put into the computer models. And then on subscale, we build small components and do break and test those to really kind of calibrate our trust in the computer models. Some of us have been doing this for a long time, so our trust in those computer models is pretty mature. So we don't build a prototype the size of this boat. You know, we build some little subcomponents, and then this boat behind us is our first prototype.
So it sounds like there's a combination. You've got a lot of computer engineering, and then you get into some physical engineering, mechanical engineering. What's your background? How did you get started with this?
Well, how far back do you want to go? I mean, you know, I grew up sailing. I always loved boats. As a kid, I kind of wanted to be a boat designer, and a few times in my life, I've strayed very far away from that. But my educational background was in engineering and composite materials, carbon fiber, and that kind of in a serendipitous route brought me back into yacht design. And I've been working on carbon fiber structures for race yachts for about 25 years now.
When did you first get involved with America's Cup?
The first America's Cup I was involved in was the 1992 America's Cup, so right around 1990.
Which team was that?
Well, at that stage I was working for a spar builder, building carbon fiber masts, and we built them for Stars and Stripes, Dennis Connor's team, and the Italian team, Il Moro.
What do you have for anyone that might be interested in, you know, we got a lot of campers out there who we're inspiring them with these, you know, amazing tales of building fast boats. What types of inspiration do you have for them to help them get involved, things that they could start looking at for ways that they can follow on a similar path than you have?
Well, you know, probably the one thing that I would say is the thing that has been the most valuable to me over my career is that I also have built a lot of stuff out of composites. You know, when I was going to university, I got very interested in building my own windsurfers. And that's when I first started to play with composites, and I've been building my own windsurfers and other things ever since. And that kind of hands-on knowledge and sense that you build is this huge enhancement to actually doing the kind of more higher-level computer analysis, because you really need to be grounded when you do that kind of analysis. So, you know, if it's whether it's composite materials or something else, getting your hands dirty is the groundwork I think you need to have. I mean, I really do.
So speaking of composites, you brought some materials to show us. What is this stuff that you've got here, and how does it relate to the boats that we've got behind us?
A few things here, and if I'm clever, I can kind of very quickly tell you what I do on my day-to-day basis and how that translates into the boat. Is we build a three-dimensional computer model of the boat and put layers of carbon fiber into it and apply loads to it and look at the stresses in those layers, then decide if we need more or less layers, or if we need to line carbon fiber up in a different direction with the loads. And what I have here in my hand is some pre-impregnated carbon fiber. So the black on the inside is a carbon fiber fabric that's been pre-impregnated with epoxy. And the epoxy is such that it doesn't react at room temperature. It's just a little bit tacky. We keep this carbon fiber in a freezer. When we're ready to start making the boat, we lay this into a mold, and it just kind of sticks there. Then we take aluminum honeycomb and some glue and apply that on top of the carbon fiber. Then we do another layer of carbon fiber on top of that. So it's all of this kind of squishy stuff. I mean, really, this is glue and string and aluminum honeycomb. And then we pressurize it and heat it. As we heat it, this epoxy resin, the viscosity drops, it flows around, it reacts, and it gets hard. And you end up with a sandwich panel construction, which is really one of the lightest, strongest, stiffest kinds of structures you can build on Earth. And this piece is flat. It's just a cutout that I actually got out of the dumpster this morning before I came over here. But this is the kind of construction that the entire boat is made out of. And some areas the carbon fiber is a lot thicker, a lot thinner. Some places the aluminum honeycomb is thicker and thinner. But you know, that's the heart of how the boats are built. And the heart of what I do is figure out how much carbon fiber to put in, how thick to make the aluminum honeycomb throughout the boat structure.
So this is what these boats are made out of.
Yeah.
We've got this thin aluminum interior with the carbon fiber on the outside.
Yes.
And this, I mean, besides providing some structure to it, does it provide any structural strength, or is most of that coming from the carbon fiber itself?
You know, the analogy of a sandwich panel construction is like that of an I-beam. And in an I-beam, you know, you have a big wide cap on the top and the bottom that take the tension and compression when you try and bend it, and a big web in the middle that transmits the loads between those two. And in this, the aluminum honeycomb does that. So it's a key part of the structure. And unlike an I-beam that does it in a discrete place, this does it over the whole surface. This is actually a piece of the boat. This is a place in the cockpit of the boat that we cut out a hatch to get inside and was just sitting in the back by the bin. So yeah, this is actually part of the boat and how we make it.
It's as hard as a board. Yeah. So these races, they're about to start. You've got to be pretty excited being on the design team. Where can we watch these races when they happen?
Well, the America's Cup race, as you know, is here in San Francisco, the fantastic venue with a lot of public areas that you can walk up to for free. There's America's Cup Park, the America's Cup Village, and the whole Marina Green. So if you're in the area, it'll be very accessible. If you're not in the area, there's a America's Cup YouTube channel that all of the races will be shown, and then also the races are shown on NBC and their affiliates. So it's very accessible to watch these races, and I recommend it. The boats are very cool.
And it's totally free for people to tune in and watch the YouTube, the NBC.
NBC and the America's Cup Park locally is all free for viewing, yes.
That's fantastic. I'm excited. These races, the qualifiers are happening right now, and as soon as the challenger is selected, you guys are up.
Match, yeah. We're very excited about that in September.
I can't wait. I appreciate you taking some time to chat with us, and excited to watch these races. This is great stuff. Incredible. Thank you very much, Kurt Jordan. All right, well, we're getting to the point now where we are wrapping up our field trip, and it's been pretty incredible. Em, what a day. I mean, some of
this place is huge.
Yeah. No, it's an incredible operation. It's finely tuned. It's well oiled. I saw some cool stuff. What was your favorite thing you saw?
Just the sheer amount of carbon fiber. I don't think we'll ever see that much carbon fiber again in our lives. It's super impressive.
No, it's carbon fiber everything here. It's cool. Yeah. So I'd like to say thank you to all of the Oracle Team USA team members that took some time to chat with us. I know this is a very busy time for them, so thank you very much, and thanks for letting us come in to the facility and take the campers on a tour. And yeah, it's been an incredible experience. And also, don't forget the Oracle Team USA. They've got their Google Plus page to check out. They're on all the social media networks. So get involved. Get to that America's Cup website so you can watch everything and enjoy it. This is fun stuff. All right. And here's them.
Yeah. So remember to add Oracle Team USA to your circles on Google Plus. And so this is day 5. This is the field trip day. It's been ridiculously amazing. We're going to be back next week with 5 really cool projects for you and another amazing field trip. So I know you can't get enough of Maker Camp, so stick around. Right now we're going to be joined by Nick Raymond, who is actually going to be presenting the weekend project powered by Radio Shack. So enjoy that, guys. Thanks again.
Yeah. Awesome stuff. Thank you, guys.
Hey, Em, and thanks so much for the introduction. Super excited to be back and helping out with Maker Camp's Weekend Project Series powered by Radio Shack. So the format will be at the end of your hangout. I will jump on and introduce a basic electronics project that you guys could build over the course of a weekend. Once you assemble all the parts and components, which you can find at your local Radio Shack, it'll take anywhere from about a half an hour to a couple hours, depending on the complexity of the project that week. As always, we'll post the instructions and step-by-step video online on the Maker Camp webpage. And if you guys build the project, we'd love to see how you guys hack and mod it. So please post your videos or your pictures and leave us comments if you have questions on the Google Plus Maker Camp webpage. So let's dive into this week. The theme was Makers in Motion. So we thought we'd bring you guys a project that shows you how to charge your cell phone when you guys ride your bike. So let me show you guys the finished project as a screen capture, and then we'll dive into the details. Okay, so now we've seen how to mount the final project onto the bike. Let's actually go over some of the major components. So first we have this bike, which is upside down, obviously, and on the frame we have mounted the AC alternating current generator. And so how that works is, as the wheel rotates, there's a shaft on this generator that actually rubs against the wheel. And so the friction between the wheel and this shaft actually causes the internal mechanical parts of the generator or alternator to rotate. That produces an alternating current at these two posts, and the voltage will range anywhere from 0 volts when the bike is stopped up till 12 volts when the bike is moving really, really quickly. So to get this electrical signal to our phone, we actually need to adjust the signal so that it's a constant regulated 5 volts DC, direct current. So to do that, we'll take from these two posts and go into our charging circuit, which uses 3 basic components. So the first one we're going to do is it's going to go into this box, and it's going to, the signal will be rectified. So we'll use a rectifying component. And what that does is it takes the sine wave that we have coming, or the alternating current, and cuts it right into DC current right away. So once we have that DC current in the circuit, we're then going to regulate that so we only go from 0 to 5 volts. We don't want to go over. As I said, if this wheel is spinning really, really fast, it could be producing up to 12 volts, and that would not be good for the phone. So once we have the rectified signal and we have it regulated with the 5-volt regulator, we then add the large blue capacitor just to kind of steady out the bumps in the signal. Maybe if you were to slow down, speed up, slow down, speed up, you want to make sure that's a nice continuous signal to the phone. That's pretty much it as far as the circuit goes. One of the tips I could offer is a strain relief knob, and you can use this actually for other electronic projects. But essentially, by adding the strain relief knot into the wires before you push them through the box, if there's all of a sudden a really, really taut tug on those wires, you're going to prevent the electronic components from being jerked out of the box. It could be a plus. Another thing is that we'll be using these crimped-on eyelets that you use to connect the different wires to certain components. In the tutorial, and then the video we'll show you at the end, they're going to recommend crimping them. That's a great way to go. And another idea you could do is also soldering them. They're just metal pieces. So what that does is sometimes when you're on a real bumpy road or there's a lot of vibrations, you want to make sure that your electronics don't kind of just shake apart. And so by making a nice solder joint at each of those connections instead of crimping them, that's just one more safety precaution. That might not necessarily always be needed, but you know, one more.
Solder's always stronger.
Another tool you're going to need is a drill. You do have to drill a hole into the plastic enclosure, which we use to then fill in the hole with a grommet. So just keep that in mind. And then the grommet is used actually to make sure that we don't get water and debris and some nastiness into the box. Keep that in mind. So let me actually go and show you guys another screen capture of the final circuit, all connected, and you'll see kind of in detail some of the components that I'm talking about. So now that the circuit is put together and it's inside your project enclosure box, you need to mount it to your bike. So we're using this grip clip, which goes through the hole that we drilled with the grommet, and we're actually using that to mount just to the post of the bike. You could mount it other places. We just found that's a pretty convenient place. For this example, I'm going to go ahead and just attach the wire leads to the alternator. For this particular alternator, they're just spring-loaded, and the wires can go in either post. And then once you're done with that, we'll try to do a live demonstration and show you guys if it'll charge the phone. So again, those just go right into the posts. I'm going to get the AC signal, and then it'll come out rectified from here. And we're just using an adapter that you can then plug in different kinds of adapters. And essentially what we're going from is the rectified signal to a USB micro cable that's good for any sort of Android mobile device. And so that'll go here, and we'll try to go ahead and spin the wheel, and you should see if I can prop this up or not. Once the wheels are moving, green light turn on, indicating that the circuit is charging. So let me try that without having the bike fall over on me. And there we go. So as you can see, you don't have to go that fast to get the circuit charging. And then as you speed up or slow down, you know, you'll still continue to charge the circuit. So that's pretty successful. Didn't fall over yet. But unplug. There we go. So that is how that circuit works out. Once you assemble all the parts and components, shouldn't take you too long. And that's pretty much it for that project. So thanks for checking out the weekend projects. To finish off, we'll start you guys and show a step-by-step instructional video that'll show you just all the ways to put the circuit together and how you can finish your project. Again, if you need to mount the phone, you can use a soft bag or something like that, mount it under the seat, zip tie it, or you can use tape if you need. And then always make sure that the cables are securely zip tied to the frame of the bike so they don't get in your way. But again, thanks for watching and checking out the weekend projects sponsored and powered by Radio Shack. And I hope you guys have a great weekend. So check out this video.
Hi, I'm M. Moto with Make. Make contributor Alistair Bland introduced us to the super simple circuit design back in 2009. It takes higher voltage alternating current, AC, from a retro-style bike headlight generator, converts it to direct current, DC, and steps it down to a safe voltage for charging your cell phone or other mobile device.
This project uses an old-style bike generator, which is technically considered to be an alternator, a very simple and reliable generator that turns rotational momentum into AC electricity. The circuit consists of a rectifier, a capacitor, and a voltage regulator. The rectifier converts the back-and-forth wiggling of the charges in AC to a steady stream of DC. The large capacitor helps smooth out the voltage levels, and the voltage regulator holds the incoming DC power down at a steady 5 volts, which is what most cell phones and other mobile devices are designed to accept. This project is relatively simple and can be easily made by following the instructions on the project page using these parts and these tools. To get started, drill a centered 1/4 inch hole in each end of the box and another in the lid. Install a grommet in each of the holes you just drilled. Then mount the clip on the outside of the lid using a machine screw secured with a nut and washers. Bend the LM7805 voltage regulator's left input lead and its center ground lead away from each other as shown. Cut 2 small jumpers from hookup wire, one red and one black, and strip the end of each jumper. Solder the red jumper to the regulator's input lead and the black jumper to its ground lead, then trim the excess from the 2 leads. Secure the LM7805 in one corner of the box using a screw in one of the mounting holes. Slip an insulated lug over the regulator's right output lead and secure to the adjacent mounting hole using a screw. Then crimp the lug with a wire tool. The rectifier's positive output lead will be indicated with a small plus sign on top of the case. The negative output lead may or may not be marked, but it will always be directly opposite the positive lead. Bend the output leads up and out from the sides of the rectifier case as shown. Bend the capacitor leads directly away from each other as well, and making sure the polarities match, positive to positive and negative to negative, stack the capacitor on top of the rectifier and twist the leads together. Next, solder the free end of the black jumper to the negative side of the capacitor-rectifier combo. Then solder the free end of the red jumper to the positive leads, as shown. Loosely secure a bare lug to each of the 2 remaining mounting holes using screws, and thread the rectifier's AC input leads into the lugs. Tighten down the screws and use a wire tool to crimp the lugs to the rectifier leads, then trim away the excess from each lead. Cut the adapter-plug cable in half and thread the ends into the box through the grommets at each end. Tie a strain relief knot inside the box on each cable and separate the individual cables on the free ends. Strip the end of each lead and securely crimp an insulated lug to each of the 4 leads. One at a time, remove and reinstall the screws from the mounting holes in the box, securing the lugs from the adapter-plug cable as shown. The polarity on the rectifier side doesn't matter, but on the regulator side, make sure the lead with the white stripe is connected to the positive output. Connect the adapter-plug micro USB adapter to the DC voltage regulator side of the adapter-plug cable, making sure that the adapter's plus sign is aligned with the word tip on the plug socket. Install the lid on the project box and secure with the 4 bundled case screws. Now your charger is ready to be installed on a bike. Attach the project box to your bike frame with the clip. Mount the generator to your bike according to its directions. Route the AC input cable from the project box along your bike frame to the generator, keeping it well clear of all moving parts. Secure the cable with cable ties to make sure it stays put. Cut off the plug at the end of the cable at the generator. Separate the leads of the cable and strip the ends of each lead. Secure the bare, stripped ends to the generator output terminals. It doesn't matter which lead goes to which terminal. Now all you need is a phone with a tired battery and you're set. Plug your phone into the micro USB adapter and secure it along with any excess cable in a bag or other carrier attached to your bike. You're now ready to recharge your depleted phone while pedaling. Charge your phone on your daily commute or use the charger to keep your music going strong with a portable sound system. And don't forget to check the project page and share your ideas, mods, and experiences.